All right, in this video, we're going to talk about ions and ionic charges. So I'm going to use sodium again because that is an element that just typically is helpful in understanding this. So sodium, as we remember before, had an atomic number of 11, and the atomic number tells us the number of protons, but also the number of electrons. So I'm drawing 11 electrons around this sodium nucleus here. So 2 in the first shell, 8 in the second, and then 1 in the third. So this is a sodium atom. 11 protons, 11 or 12 neutrons. Remember when we talk about isotopes, in this scenario, it doesn't really matter. The nucleus kind of stays constant. But we have 11 electrons in a sodium atom from the periodic table, a neutral sodium atom. And that is an unhappy atom. Okay, I kind of just like to think of it like that. It's not satisfied, it's not happy. So what sodium likes to do is it likes to get rid of that outer shell, that valence shell that had the 1. It basically vanishes and the electron is up for grabs. Now the sodium atom is happy because it has 8 valence electrons in its outer shell. So this is a sodium ion. 11 protons, 11 or 12 neutrons, still the same as before. But now we have 10 total electrons, and that, it's not specifically important about the total number of electrons, but the total number of outer electrons or valence electrons. There are 8, and that is what atoms want to have. They want to have 8 valence electrons. So in this ion that we're looking at, we have 11 protons, which means, I have a positive 11 charge, and I have 10 electrons, and that's a negative 10 charge. So I'm no longer neutral. Now my overall charge is a +1. So this sodium ion has a charge. This is the ionic charge of sodium, is a +1. So let me just erase this. And then I'm going to look at this periodic table. This is in your green packet. So if you look at group 1, where hydrogen is, the very left column, sodium is in there. Sodium, all those elements there have a +1 charge. The next group has a +2 charge. Then we skip the transition elements. Then we have +3, +4, and then we have -5, -6, 5, 6, 7, and then 8. This is telling us how many valence electrons they have. So if we look at chlorine, chlorine has 7. Sodium has 1 in its outer shell. And I'm going to go back a second because I think I said I'm going to actually, instead of saying that they are a +1 charge, I'm going to say in these columns there are 1 valence electron, 2 valence electron, 3, 4, 5, 6, 7, and 8 in your noble gases. That's the number of valence electrons. I think I said charges earlier, but it's the number of valence electrons, 1 through 8, okay? Skipping those transition elements. So now looking at chlorine, chlorine has 7 outer electrons. Sodium has 1. So we're going to go back, and this will make sense once you see this, but sodium Again, I'm going to show a sodium ion with that electron that's up for grabs. Okay, so this is our happy ion with this positive 1 charge. And then we have chlorine, and chlorine was in group 7, which means now it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 17 electrons total, but specifically it has 7 in its outer shell. And this is an unhappy ion because it's got this empty space that it wants to fill. So sodium is happy to donate its outer electron and give it to chlorine. That makes chlorine happy because now it has 8 as well. And it also now has a charge too. It has a -1 charge. So your charges are determined on whether or not you're gaining or losing electrons. If you gain electrons, you're going to have negative charges. If you're losing outer electrons, you're going to get positive charges because you'll have more protons than you have electrons. So I hope that makes sense. Talk to me if you have questions.